Okay, so what we want to do is that we want to create a low pass filter. If you remember from electronics, I'm sure you have seen this before. This is a low pass filter. Sorry, this should be 1K actually. Let me draw it again. So what do you need for a low pass filter? You need an amplifier or op amp. So if you again remember from your fundamental classes, op amp comes with the form of IC, right? I think the one you have is UA741. So that's one thing, or LM741. So that's an IC for op amp. And it comes as SMD or through hole. So that's one thing you need to make a filter. Now, what else do you need? You need 2 resistors. This is called feedback resistor, and another resistor here, and then it goes to your input. So a signal is coming in, and then if this is 10K, and this is 1K, and this is V out, and this is ground, this is a low pass filter. And V out, this is a filter. This is an amplifier. This is an amplifier like this. Why? Because V out over V in is negative feedback amplifier. So it's this over this, right? So that's an amplifier, but now this is minus, this is plus. So whatever you have at the output over the input is minus this feedback resistor RF over Rin, meaning that whatever I have at the output is, for this case, 10 times whatever I have at the input. It's just its phase change. So this is an amplifier. Now, if you put a capacitor on top, then that will become a low pass amplifier. Again, why? Because capacitor is a component that acts differently to different frequencies. When frequency is low, it will charge up and it will hold the voltage here. If the frequency is high, it will act like a short. When it acts like a short, whatever you have at the output is equal to whatever you have at the input. For low frequency, when it charges it up, then it holds basically voltage here, and this will always be true, right? So this is a circuit. Let's say I give you this circuit and I ask you to build it with Eagle. The first thing you have to do, and then the way you look at it, you say, okay, I have resistor, capacitor, and an IC here for this. And then you need something that you haven't seen before for V out and V in, right? You need some pins for your input and output. So when you have a signal going in, you can see your signal coming out. I'm going to use surface mount for all my components today, okay? So what you can do is go to Eagle and create a project called low pass filter by going to File, New Project, and then right click on it, New Schematic. So that's the first step. You put the schematic here, and it's a good idea to put the grid on. So you can put everything in order for housekeeping. Okay, so once you do that, then you have to add your parts. So you go and scroll on this and press on it. Okay, now what I need is 741 IC So one way to search is you can put a star and say, okay, I want LM 741, a star, and anything with 741 and LM will show up. And press OK. So this is what I need, op amp, and this is the symbol for op amp. So this one is actually in Eagle PCB library. And you see there are two kinds. When you click on it, you'll see the difference. This is surface mount. This is through hole. So I'm going to choose the surface mount. Okay. And you click and then escape. It's here. If you press one, it was better if I press escape once, then I have still my library. Now, the next step is, okay, what else do I need? Then you go back and see what else do you need. I need resistors, right? So now that you're comfortable somewhat to work with Eagle, it's good to know that when you go to part, and if you need, cancel. Okay, so if you need resistor or capacitor or inductor, look for RCL library. RCL stands for resistor, capacitor, inductor. So if you go and find R, you should find RCL library, which is an Eagle library. If you click on it, you would see capacitors, you would see inductors, you will see resistors. And there are different kinds of resistors. So this is European symbol, which is like a rectangle. This is US, American. And so I'm going to US and I open this. And then there are different kinds. If you click on them, you will see. So what I'm going to do is just choose. So the part I want to use is 6R0. So R0, which is R063, maybe this one. Okay. So this one is, as you see, is surface mount. So because I said I want to use surface mount resistor, so I'm going to use this one, for example. Okay. What happened? It didn't come. Oh, okay. So again, I go to RCL. I go to R US and I'm looking for R06. This one, the surface mount one. Double click on it and it will come. Okay, so how many do I need? I need two. One for the feedback resistor and one for the input. Okay. Now, what else do I need? I need capacitor. So in the same library, you can find capacitors. So for example, it really depends on the application. I'm just using randomly the one that I know that are surface mount. So if I use European C0, like maybe this one, yeah. So this one is surface mount as well. So I'm going double click and put it here. Okay. What else do I need? I need, first of all, I need supply. So going back, look at the circuit. Okay, I have all my parts, but I need ground. And as you know, you have to power up your IC with, for example, 15 volt, minus 15 volt. So you have to power it up. There are two pins that you assign. At one point, your amplifier should get to threshold. So there are two other pins that, if you remember from op-amp lessons, you have to put power into. So that's one thing as well. So what you can do is you go to your schematic. For that, you need supply because you're supplying power, right? So here you see you have all these voltages. So supply 2, I need ground and 15 volt and minus 15 volts. So this is 15 volts. So double click. I need that. What else do I need? I need minus 15 volts. So I should go to minus, double click, put minus 15 volts, and I need ground. Ground. Okay. And you put ground. Now, another thing I need is pin header. Pin headers are used to, they look like this if I want to show you. I'm sure you have seen them on PCBs. These are basically used for connection, right? So they have different types, and you can find it in Eagle. You have to go to, if I can find the library, CON. On LSTB. No. Let's see. No, it's not there. So I have this, and then con LSTB, if I can find it. And then there's one. These are all pin header, okay? So you can find it in connection library. Now, if let's see which one is good. So the one I'm using, it has 3 pins connected to it, but I know I need 5. I need 5 connection pins. So let me go to 05. Okay. So when it's 05, that means I have 5 pins coming out, connections. So if you press on OK, then that will be my pin header. Okay. Now, escape. These are the parts I need. I need this pin header because, as you know, I need to, I have in my schematic, I have input and output. So when you have input and output, usually you need some kind of connections. That's where pin header comes to life. And as I showed you, it just looks like this, that you solder on the board. So now that I have everything, I can make it look like the schematic that I drew here. So the rest is just putting wires and make it basically pretty. So the output can go to one of the pins here, which is pin 5 is on top. So maybe it's better to, if you want to see better. So you can put pin 1 on top by clicking on it and rotate it. Actually, maybe. Okay. Can't see. And then mirror this. Oh no. Mirror. Okay. So now 1 is on top. So this will make a mirror image of your component, and this will rotate it, and this will move it. So now that I have this, this capacitor should be turned, right? So what you do, if you remember, I said you have to find these lines sticking out, and that will help you to rotate it. Otherwise, it wouldn't work. So now it's rotating, okay? If you want to move it, you press on move, and then click on that small line again, and you can move it. And you can move this as well. Come down. So this is the feedback resistor, so it should be on top. And this capacitor will go on top as well. And this is the feedback. This is minus, but it's better to be on top because my input goes to minus of my op amp. So you can, you can go to mirror it, and then rotate. Okay, so now minus is on top, plus is down. And then pin 4 and pin 7 are for power supplies. Plus to plus, minus to minus. This is mine. Then you go to move, and you have to bring it up. And move. You know, it makes that sound if you don't click on the line. Now, pause. Bring it down. Plus, you bring it down. Minus, then you have to turn it. Oh, these two got connected. We don't want that. Control Z. And then you can turn that. You go to rotate. You turn it. And then you connect it to, then you have to move it. So for each step, you have to go back and choose the right tab. Then you come and connect this to minus, and this plus you have to rotate it. And then you have to move it. So you come to move, and then you go back and you move it and put it there. Okay. So that's for op amp. Then if you want to zoom to fit, we'll make everything in a way that the user can see all the parts. So whenever you get lost and you want to see all the components, just click on zoom to fit. Okay, so what else then? My output, I wanted to go to the output pin so you can connect it to, and before doing that, this ground should be connected to pin 3 as in the schematic, right? So I go back and I connect pin 3 to ground. If you remember, net is the wire, and they are air wires. They are not actual wires. So when you go to the board, making the board part, you have to put real wires. And you can, now that you have it, you can connect these two. And also you can connect your capacitor. Click, 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 which is your output. And pin 6, your output will be connected to one of the pins of pin header. So you can come down, click again. Wherever you want to move, you have to click. Click again, go up, click, pin 5. So that the output will go to one of the pins then on the board. Now, what about the input? Input, you can connect it to another pin, let's say pin 4. These are all depends on what you want to do. It's not set in stone. You can change the pins. You can assign whatever pins you want to. They're all the same to input, output. These are not connected, so that, and then what you have to do is connect your positive negative ground to your pin header as a reference. So you have to put, you can copy paste this. I think if you click twice, you can bring it. No, Control Z, Control Z, Control escape, because it's still on wire. So you have to do escape. Then if you go double click on 15 volts, where is that small line? If you double click on it, I want to copy it. So okay, right click, copy, and then you can connect it to, make it smaller, to 15 volts. This is 15 volts. Okay, and I need a copy of this as well. Right click. Oh, now it's working because I'm in a copy mode. So whatever I click will be copied, and ground as well. And it will come here. Okay. Escape. Now for pin header, you have to connect all these, whatever powers you have. 15 volts, you have to turn it. Okay. So now you go to, you click on it, and then you have to move it. So you go to move, and you go to 5 volts there. Then this one is ground. You can connect it to 2. So then you have to go to wire again, pin 2. And this minus 15 volts should be connected to pin 3. Now it's there by itself, so that's where your artistic side should come up, because if I bring it here, it will be messy. So I'm going to make it bigger and give it some room so it wouldn't look bad. So what I'm going to do, I'm going to move this. I'm going to move the ground out of the way as well. But it's not a good wire, so I'm going to delete this wire and put a good looking one, like I can go like this. Escape. Now there's some room for this, so again you go on move, and you have to find that a small line, as I said, and you bring it, and then you have to rotate it. So you press on that and a small line, rotate, rotate, and then the line is net, so you connect it. Okay, escape, escape. So I was able to, now there's something here missing. These should be connected as well. Now it might look right, your design, but you might get some errors. And I don't know if you remember, but yesterday we talked about how we can check the errors in the schematic. So instead of doing it at the end, you can, once you make your schematic, you can check if there is any error. And that's just by typing ERC. So I don't have any errors, but I have some warnings. So here it says part C1 has no value, this has no value, this has no value. Okay, so I didn't put any values for my resistors and my capacitors. Again, if you remember, for values, you should go to this value, and then you click on the value. Okay, so I'm doing something. Okay, so you have to click on the resistor itself. It's 10K. Press OK. And this one is 1K. Once it's in one mode that you clicked here, then it's there. You don't have to click again. 1K. And the capacitance, capacitance is 2 microfarad. So I said it's 2 microfarad, so you can say 2 microfarad. And then you can do ERC again. So those warnings disappeared. I still have some warnings. SV1 has no values. It's okay because I'm using them as connectors. Power pin connected to minus. Yeah, I did all of them, and I don't have any errors. Warnings are just for you to double check, so that's fine. Okay, so I was able to go from a circuit to its corresponding Eagle schematic. Then the next step would be for you to come up and generate switch to board. Create from schematic, yes. Then here your job is to just drag them here, okay? Now that you know the steps at least, just want to tell you something about the wires. When you want to make a board that is actually flawless and to make sure that you follow all the rules, one thing you have to be careful is that never make two wires parallel to each other. Avoid this. Why? Because even in breadboards, the thing that will happen is that, as you know, that it will be, what will happen is called capacitive coupling, because you have charge, and then because of that, these two wires will act like capacitors, right? And the coupling will happen between these two wires, and that will create eventually into noise, and the outputs that are not clean or deviate from your original signal. So one of the things that you have to be careful is that. The other thing is that to avoid any noise and interference, it's important to keep your wires short. So that's another thing. Now, when you go to, that's one of the things that you have to be careful when you move your wires around. So now I just do this and connections. Maybe put this on top here and bring these down. And this here, okay? Something like this. And then manufacturing. And this will be the PCB board that they will make for me. Okay, so but there's something missing that I didn't do, which was the wires. So if I do checking, I'll get an error. So who remembers what kind of checking should I do? So last time I talked about two kinds of checking. One was ERC, the other one was, so ERC is for schematic. DRC, design rule checking, is for the board. So you can do DRC. If I do DRC, I should get an error that I didn't put the wires. Check. So you see I get 10 errors. All of them are for wires. Air wire, air wire, air wire. So these are, as I said, air wires. They are not real wires. So one way to get real wires is just type auto, and then it will come here. So now if I say DRC, Eagle design rules check, and I didn't get any errors. It's here. You see DRC, no errors, as you see here. So now you can type on manufacturing and you get your board. Okay.